Caves are amazing places. I say this as a geologist and environmental scientist, but also as a curious human. Through caves, we can see firsthand how an aquifer works. Through caves, we can reconstruct past climate, and through caves, we can observe some unique creatures and their habitat. We'll explore this through a trip to a cave deep in the heart of Texas, and you could join us as a student and do the exercise to see what you've learned, or you can just come along for the ride. Welcome to Inner Space Caverns near the city of Georgetown, Texas. Right next to Interstate 35. Just take exit 259 off the interstate and you'll be at Inner Space. Come join us as we explore the cave and reveal its scientific secrets. As we get into what we can learn from caves, maybe the first question to ask is, what is a cave? Basically, a cave or a cavern is a big hole in the ground. How big does it have to be before we call it a cave? Well, if a human can fit inside of it, it's a cave. A cave is nothing more than a very enlarged pore. In geological sciences, we're really interested in pores within rocks. The amount of pores, their size, how connected they are. We worry about pores in geological sciences so much because that's what defines a resource. The resource may be an aquifer, which is an underground body of rock that yields usable amounts of water, or the resource may be a reservoir for petroleum. Carbonate rocks, such as those that make up the host rock for the cavern here at Inner Space, are among the most important aquifers and petroleum reservoirs around the world. Before we go into this cave today, we'll address two main questions. Number one, how do caves form? And then two, how do the formations in caves, like stalagmites, form? But first we'll ask, why should we even bother studying caves? There's a few things that are really important about caves. Caves are a rare window into an aquifer. If you think about it, how would we get information about this underground world if we didn't have caves that allow us to crawl or walk right into it and see from the inside out how the aquifer operates? It would be really difficult. We would have to drill a well, or even then we'd only be getting a very small view, almost a microscopic view, relative to the scale in which we can see processes within a cave. So that's the first important reason we study caves. The other reason we study caves are the mineral formations that grow in them. These are called speleothems. Speleo comes from the Greek root speleon, meaning cave, and then from the Greek word them, which means them things. So speleothems are them things that grow in caves. Actually, I don't know what them means in Greek. Speleothems are called stalagmites if they grow up and might make it to the ceiling one day, and if they hang tight to the ceiling, they're called stalactites. If they grow together, they become a column. It turns out that speleothems are very useful records of past climate. This may be recorded in some physical feature of this speleothem, such as how fast it grows, or some chemical feature of this mineral formation. So this mineral deposit grows from water dripping into the cave, and it may preserve changes, for example, in the amount of rainfall or temperature that's occurred in the past. This can happen over timescales of decades to centuries to many thousands of years. A third reason we might study caves is that they are unique habitats for a variety of creatures. There are a lot of creatures that either live in caves that are unique or wandered into caves accidentally or purposely and wound up getting preserved in the sedimentary deposits in caves. Okay, so that's three important reasons to study caves. Onward.